कैसे हो दोस्तों? You know that very well. Already we are discussing about chapter number 6, EMI, electromagnetic induction. But today we would like to think about part 4. In part 3, we discuss supreme topic, motional EMF. You know that very well. The formula for motional EMF, epsilon is equal to BLV, where B representing magnetic field, L representing length of the rod or conducting body, and V representing simply the speed inside the magnetic field. And we discuss supreme topic like formula for motional EMF. After that, what is the reason behind the origin of induced EMF? Because of the motion of the body, and the conservation of energy. That means whatever the mechanical work is done, this mechanical work is available in the form of electrical work or electrical power. So friends, today, particularly in this part 4, we would like to cover all numericals associated with motional EMF and some JEE NEET related questions. So very important, definitely most timely lecture for NCERT point of view plus JEE NEET. So friends, you can see just in front of you there is a diagram. These are the magnetic field lines. You can see crosses. These cross lines indicating that magnetic field lines going inside this plane of this board. So magnetic field already going inside. Particularly in this magnetic field, there is a circular ring. This is circular ring, you can see. And at the center, there is a metallic rod is placed. This is the metallic rod. And this metallic rod simply performs motion in such a way that this outer end of this rod continuously in contact with, you can see that this circumference of this metallic ring. So this is metallic rod, this is metallic ring. Metallic rod continuously performs circular motion about this, you can see that center and about the circumference of this metallic ring. So obviously this metallic rod performs motion inside the magnetic field. So you know that very well, because of the concept of motional EMF, induced EMF is produced. You would like to derive the formula for the induced EMF, or I can say that motional EMF get induced due to the motion of this metallic rod. So friends, be alert. This is the most time and damn sure I can use here one word, 2021. Why? We check it, don't worry. So this question can be solved by using two different ways. First of all, I would like to solve, we can say that by using first preference method, and then we'll think about the second method. So you can see, suppose this is point O, this end is A. Initially this rod is OA, but after some time this rod performs motion and available at this position. Initially it was situated at point OA, initially OA position, and after that you can see because of the motion, now this rod is situated at point OB. So this is new position of this rod. Obviously this rod performs rotational motion or circular motion, so there is some angle is covered by it. This is, you can see that angle theta. Okay, now you can see there is a loop OAB. This is loop, you can see like this one, OAB. You can see. So this rod covers, you can see that some area. Obviously O to A to be this area. So this is the common, we can say that question or common point like motional EMF related discussion. Yaad karo part 3. Any conducting rod slides over the two arms, then there is a rectangular loop here. This type of loop is formed OAB. This OAB enclose this area, or we can say that some area is covered by this loop. Obviously this rod continuously moves, or I can say performs circular motion. This area would be increased, or I can say that there is some change in area. Area, you know that very well. If area is changed, change in area leads towards the flux, because you know that magnetic flux is equal to area into magnetic field. So here area is changed, or area continuously changes, so obviously magnetic flux also changes. So change in magnetic flux, that means induced EMF. So first of all, we start with the first point, is conducting rod performs circular motion. So as shown in diagram, loop OAB, or as shown in diagram, I can say area of loop OAB obviously changes. You can see the area changes continuously because of the motion. So first of all, we would like to find area. You can see here area, but why? What is the reason that area we are thinking about area? This is the most important part, because we would like to think about magnetic flux. So area already changes, so we can say magnetic flux associated with loop OAB will be changed. Ready? So first of all, what is the magnetic flux? You can see magnetic flux associated with loop OAB. This loop OAB, you can see. So magnetic flux phi is equal to area enclosed or covered by loop OAB multiplied by magnetic field. You know that very well. In short, what is the next target? Next target to find the area covered by this OAB loop. ये इंटरेस्टिंग है, बस इसको भेजा मतलब ये न्यूमेरिकल कंप्लीट. So tell me, how can you find the area enclosed by this loop OAB? इतना एरिया कितना होगा वो हमें फाइंड करना है. So we'll apply some concept of reference study. What's the meaning of reference study here? Already one reference with us. What is the area of this entire circular region or entire circular metallic ring? You can see the ring. Obviously area of radius capital R, pi r square. So for pi r square area, what is the length of the ring? The length of the ring is 2 pi r, because r is the radius. So for 2 pi r length, what is the area of the region? Pi r square. तो अपने को मैं first of all एक sentence जिसे कह सकते हैं कि reference मिल गया. You can see like in this way here, for 2 pi r length, area already pi r square. पता चला? You can see what is the length of this region, 2 pi r. For this 2 pi r length, what is the area? Pi r square. So we are discussing about this portion. What is the length of this region? Arc AB. What is the length of arc? Length of arc, you know that very well. Here, length of ABR. This is ABR. What is the length of arc? Length of arc, that means angle multiplied by radius. So here angle theta, and what is the radius? It is r. So for 2 pi r length, what is the area? Pi r square. So therefore for theta into r length, what is the area? Area simply pi r square multiplied by theta into r upon 2 pi r. Understand or not? So therefore we can say area of loop OAB is equal to, what is the area of this loop OAB? Is equal to r cancel, pi cancel, theta into r square by 2. This is the area of this loop. Once you have idea about area, then this numerical becomes very easy. Now you can see that, so we can write. So magnetic flux phi is equal to area multiplied by magnetic field. Area enclosed by loop OAB. What is the area of loop OAB? It is theta into r square by 2 into magnetic field. So this is your magnetic flux. But here you can see magnetic flux doesn't remain constant. Why? What's the reason? Because continuously the value of theta changes. As this metallic rod performs circular motion, then continuously value of theta changes. So obviously there is some changes appear in theta. So magnetic flux also changed. You can see that or some magnetic flux also get changed. So change in magnetic flux. So induced EMF. So we can set up this value. So as per Faraday's law, induced EMF induced EMF epsilon is equal to, you know that very well, it is d phi by dt. Here we have not considered minus sign. You know that very well, minus sign is present in this formula of Faraday's law. This minus sign representing Lenz's law, simply represent opposite direction. So epsilon d dt, what is the magnetic flux phi? Already with us, theta into r square b upon 2, you can see that. So obviously in this entire equation, if you think about constant term, so r into b, yani r square into b upon 2 constant, because here only one quantity continuously changes, it is theta. So theta is the angular position. Tell me, with respect to time, if angular position continuously changes, there is some change in angular position of the particle, then check the chapter number 7, rotational motion. What happened? Changing rate of change of angular position, this d theta by dt gives idea about you know that very well, omega. This is called angular speed. What is the angular speed? Angular speed of this rod? It is omega. So omega already I have represented here. So final answer 1/2 b omega r square. This is the Dhum equation, and very important JEE NEET concept. ये सीधा concept apply करना है whenever they ask this type of question or associated with this type of situation. You can see from today, any metallic rod performs circular motion with some angular speed omega inside the magnetic field B, and the radius of this circular motion is capital R, then whatever the induced EMF produce, it can be given by equation 1/2 b omega r square. Very IMP point. This is the methodology. We have discussed first method. Sometimes what happen, the value b omega r given, suppose here the value b given, suppose it is 1 Tesla, and omega, you know that very well, not given but frequency given, so omega is equal to 2 pi f, and the radius of this point also given 1. So if you simplify, f given 50, if you simplify, then 157 volt. This is the EMF produced across these two ends of this rod because of the motion, and you know that very well. Last lecture, chapter number 6, EMI part 3. Any conducting wire passing through magnetic field, then you know that very well, this conducting rod behaves like a battery, and this now rod behaves like a battery and produce EMF. What is the formula of this EMF? BVL. Similarly here, this is, you can see that EMF. Why? Because this rod now behaves like a battery. And what is the potential difference across these two ends of the battery? It is 157 volt for the given situation. This is very IMP, and you can see this is your unsolved number, illustration number 6.6, and I can write here 2021. damn sure equation for 3 marks. ये 3 marks के लिए 2021 में है ही समझ लो. And whatever the result we have obtained, don't forget this result, masterpiece. It is one of the very important concept for JEE NEET. So B group or A group, इसको खास याद रखना है. Any time a metallic rod performs circular motion inside the magnetic field with angular speed omega, then whatever the induced EMF is produced, it can be given by equation 1/2 b omega r square. B magnetic field, omega angular speed of the rod, and r is the radius. I can say the length of this rod also. One of the masterpiece, and you can see whatever the method we have applied here. What is the most important point about this method? Area. You know that very well, as this rod moves or performs circular motion, whatever the area enclosed by this loop OAB continuously increases. So change in area obviously leads towards one word. You know that very well, magnetic flux. So first of all, magnetic flux associated with this loop OAB, it is area multiplied by magnetic field. So you target to find area enclosed by this loop OAB. So what is the area enclosed by this loop OAB? So how can you find area? This is the most important region. इस न्यूमेरिकल का सबसे important portion यही है. So you have to focus about this portion. You can see how can you find the area enclosed by this OAB loop. It can be found by applying this concept. First of all, what is the length of this entire metallic ring? So for 2 pi r length, what is the area? It is pi r square. So for this length of arc AB, what is the area? and you can see we apply the concept. Superb. After that area, with you, then you can easily find magnetic flux. Then simply differentiation because of Faraday's law. So we'll discuss second method, don't worry, but just analyze. This is your illustration 6.6. Refer the textbook and try to synchronize. Superb. रेडी. सो नाउ ओके, अगर आपको ये मेथड सेट नहीं होती तो दूसरी मेथड में इसलिए कहता हूँ क्योंकि दूसरी मेथड है वो बहुत ही इंपॉर्टेंट है, जो न्यूमेरिकल्स के लिए है, कुछ जेडबल नीट के लिए भी इजी रहेगी. तो मैं दूसरा मेथड है वो आपको खास कहता हूँ, वो अच्छी तरह करना. ये मेथड है वो ठीक है, नो डाउट आपको याद रहे तो ठीक है, बट सेकंड मेथड जो अपन लोग डिस्कस करने जा रहे हैं उसके ऊपर खास फोकस करना है. ओके फ्रेंड्स, सो बी अलर्ट. और खास तो मोस्ट इंपोर्टेंट पॉइंट है प्रैक्टिस. ये टाइम है प्रैक्टिस का, तो खास जरा भी टाइम गवाए बिना ये सभी चेक करो अच्छी तरह. ओके, सो नाउ कंसंट्रेशन रिक्वायर्ड. फर्स्ट ऑफ ऑल, this type of rod, you can see this is metallic rod. Once again the same data, metallic rod performs this type of circular motion but inside the magnetic field line going inside this plane of the board, like this one. Exact scenario if you like to check, then I can say, okay, just a minute. Okay, suppose this one is the plane and this is magnetic field going inside, and this rod performs this rod performs motion like in this way. Magnetic field already going inside the plane. Now second method. Once again you can see there is a rod. Now for this second method we will consider only a small portion. Consider a very small portion. अब ऐसा बता देता हूँ. Very small portion, you can see that this is the small portion of this rod having length dr. And let the distance of this considered portion from the center, it is r. So we'll write, consider a very small segment of length dr at a distance small r from center O. You can see it. Ready? So we have considered a very small segment of length dr which is situated at distance small r. अब ये पूरे न्यूमेरिकल में we have to focus only on this considered small segment. बाकी सब भूल जाओ. ये देखो पूरा जो रोड है उसका इतना पोर्शन मैंने ले लिया, ये रहा इतना पोर्शन. अब ये जो पोर्शन है कंसंट्रेशन रिक्वायर्ड है, सपोज इतना पोर्शन, if you consider the entire rotation or entire motion, ये पूरा रोड ऐसे मोशन करता है, तो उसके बदले अपन लोग अब ये पोर्शन लेते हैं, ये पोर्शन भी ऐसे मोशन करेगा. यू कैन सी लाइक इन दिस वे, इतना पोर्शन यू कैन सी. This portion simply performs rotational motion inside the magnetic field. In short, this portion performs motion, and you know that very well. Any conducting material perform motion inside the magnetic field, then there is induced emotional EMF. So, without thinking about entire rod, we are present time thinking about only this small portion dr. So, first of all, consider a very small segment of length dr at a distance small r from the center O. You can see. Okay, next. अब अपन लोग इसके ऊपर ही फोकस करेंगे. Because of this motion of very small segment, you know that induced EMF is produced. So we'll write the motional EMF is produced due to motion of considered small segment is suppose d epsilon. Why d epsilon? Because we are discussing about very small segment, that's why. So d epsilon, what is the formula of motional EMF? It is BVL. So magnetic field B, V here you know that very well. V, suppose we have no idea about V at present time speed, and L. What do you mean by L? L, that means the length. what is the length of segment? Already dr, so bv into dr. But this portion performs circular motion or rotational motion. Chapter number 7, if this portion perform rotational motion, then you know that very well. Here v is equal to omega r, because this portion performs rotational motion with angular speed omega, so v is equal to omega r. So in our case you can see that v is equal to omega r, so d epsilon is equal to simply b instead of v omega r dr. So this is, you can see that your motional emf, no doubt this is the motional emf, but because of very small portion, but we have to consider entire rod. So how can you find the total emf? Obviously for very small segment, whatever the motional emf, it is d epsilon. So if you consider entire rod, so you know that very well, we have to think about integration. So the total motional emf is induced in rod or across the rod is given by equation epsilon is equal to integration of d epsilon. So if you set up the value d epsilon b omega r dr, but we have to think about finite length rod. You can see this length is finite, so what should be the integration limit required? पहले तो देखो इंटीग्रेशन लिमिट का फंडा बनाते, b ओमेगा कांस्टेंट r dr, a dr चिल्ला चिल्ला के बता रहा है, कृपया ये जो r रिलेटेड टर्म है उसका इंटीग्रेशन करो और लिमिट भी r यानी डिस्टेंस के फॉर्म में सेटअप करो. So you can see here rod starting from this point and ending at this point. So what is the length of this rod? So length of this rod, that means simply the radius, capital R. So we have to consider simply integration from 0 to r, यहाँ से लेकर यहाँ तक, क्योंकि जितने भी सेगमेंट्स लेंगे वो रोड के ऊपर लेने वाले हैं, और अपन लोग जानते हैं कि यहाँ से सेगमेंट लेना शुरू करेंगे ज्यादा से ज्यादा यहाँ तक ले सकते हैं, उसके बाद नहीं, यानी लिमिट होगा 0 to capital R. Okay, so epsilon is equal to b omega. What is the integration of r? It is r square by 2. So epsilon b omega, if you set up limit r square by 2, so epsilon is equal to b omega r square by 2. Check it, you can see that. So this is the induced EMF across this type of rod. Most IMP. तो ये जो क्वेश्चन है बहुत ही इंपॉर्टेंट है, इसमें थोड़ा मॉडिफाई भी कर सकते हैं, इसमें वैल्यू रख के आंसर 157 वोल्ट लाना है आपको, नो डाउट. दिस इज योर इलस्ट्रेशन नंबर 6.6. ये मेथोडोलॉजी बहुत इजी और आईएमपी, सो इसको खास फॉलो इसलिए क्योंकि दूसरे न्यूमेरिकल्स भी होंगे. अब इसमें कैसे क्वेश्चन पूछ सकते हैं जेडब्ल्यू में? सपोज इंस्टेड ऑफ दिस टाइप ऑफ रोड, समटाइम्स दे प्रोवाइड, यू कैन सी दैट दिस टाइप ऑफ व्हील हैविंग n नंबर ऑफ स्पोक्स. You know that this तरह साइकिल के व्हील में स्पोक्स होते हैं, and this entire wheel, this wheel you can see that like in this way, inside the magnetic field. This entire wheel performs rotational motion with angular speed omega, Then suppose there are 20 spokes here, then what is the total induced EMF because of the rotation of these 20 spokes? तो काफी स्टूडेंट्स क्या करते हैं, एक का इतना आया तो मल्टीप्लाई बाय 20 करते हैं. दिस इज द बिगेस्ट, यू कैन सी दैट द प्रॉब्लमेटिक मूव फ्रॉम योर साइड, बिकॉज दिस ऑल स्पोक्स आर कनेक्टेड बाय मींस ऑफ पैरेलल वे. You can see they all are connected in parallel, and you know that in parallel combination, for parallel connection, EMF potential remains constant. So whatever the PD across these two ends, it is suppose 157 volt. So across any end, it is 157 volt because they all are connected in parallel. So number of spokes are given 20, 40, 60, but don't forget EMF remains constant. ऐसा क्वेश्चन भी पूछेंगे मोस्ट IMP, तो इसके पूछने के चांसेस जबरदस्त. 2021 का ये हीरो बन सकता है. चैप्टर 6 का आइडियल न्यूमेरिकल आई कैन से. अब मैं आपको इसके जैसा क्वेश्चन देता हूँ जो ऑलरेडी JEE में पूछा हुआ है, तो आपको ट्राई करनी है. ओके, सो ट्राई टू, वी कैन से दैट सॉल्व दिस क्वेश्चन. ओके, मेथोडोलॉजी आपके सामने ही है, आप ट्राई करना, नो डाउट. फिर अपन लोग ट्राई करते हैं. ये न्यूमेरिकल को इस तरह सॉल्व करना है, नो प्रॉब्लम. देयर आर टू मेथड्स गिवन. फर्स्ट ऑफ ऑल वी हैव covered the first method, and then this is, you can see that your second method. तो अब जरा इधर ध्यान, मोस्ट इंपोर्टेंट. सपोज दिस टाइप ऑफ plane surface is given and there is a string, and at the free end of the string there is a rod, metallic rod of length L. This is your metallic rod. You can see what is the length of this rod L, and this distance is given 2L. Length of string is given 2L. If this rod performs this type of circular motion with angular speed omega inside the magnetic field B, magnetic field already perpendicular, don't forget. These are the magnetic field lines. Ready? If this metallic rod of length L performs rotational motion with angular speed omega inside the magnetic field, then find the induced EMF produced across the rod or inside the rod. Start. Think about it. Pause the video and apply your logic. Okay, आप में से काफी लोगों ने ट्राई की होगी. First of all, you can see that we would like to apply the same concept. Here 0 to R, B omega, ये फिक्स हो गए यहाँ तक देखो. Very small portion ऐसा करके इधर. So epsilon is equal to 0 to R, B omega R dr. ये स्टेप तो कॉमन ही रहेगा. You can see here B omega out of integration R dr. But what should be the limit? Limit plays very important role in this entire question. You can see here, this is the starting point and this is the ending point. So total distance 3L. Okay, from this point to this point. मगर काफी लोग हैं वो लिमिट लेते हैं 0 to 3L. ये चिकना केस और यहाँ पे लोग फिसलते हैं. ये दोस्तों स्ट्रिंग है, स्ट्रिंग. अब ये धागा मैग्नेटिक फील्ड में धूम ना मचाए. धागा घूमेगा तो कोई इंड्यूस्ड ईएमएफ प्रोड्यूस ना हो. सो डोंट कंसीडर द मोशन ऑफ स्ट्रिंग. Here magnetic field is produced due to motion of only this metallic rod, conducting rod. So what should be the limit? So conducting rod starting from this end and completed at this end. So what is this limit with respect to this motion point? Yeah, okay. So 2L to 3L. So limit should be 2L to 3L. देखो ये अब इसमें इंटीग्रेशन करने का है तो देखते हैं. जिसे कह सकते हैं कि अपन लोग इधर पे पॉइंट टू पॉइंट इसमें जिसे कह सकते हैं आंसर दिया नहीं है, इसलिए हम लोग फाइनल पहले डिराइव करते हैं. सो 2L to 3L R dr. So what is the integration? R square by 2 2L to 3L. So B omega by 2 instead of R square. Here 3L the whole square minus 2L the whole square. Upper limit minus lower limit. So induced EMF B omega by 2. Here 9L square minus 2L square. That means 4L square. That means 5L square. So answer 5 by 2 B omega L square. And those students who have obtained this answer, they all are right. Super. तो ये क्वेश्चन देखो ये ऐसा ही डिट्टो. This is your illustration number 6.6 and you can see this is the question from, you can say JEE 2013. देख लो 13 वो क्या होगा. You can see 2013. So 2013 में क्वेश्चन पूछा हुआ है. Little bit you can see that change. So if you have enough idea about 6.6 NCERT again, and you can see very interesting. So think about this methodology. Most IMP analyze. Okay friends, so we would like to think about one more about this type of question or based on this type of question. अब मैं आपको एक क्वेश्चन दे रहा हूँ, आपको सिर्फ ट्राई करनी है, बराबर. And now you understand, any conducting rod of length L performs rotational motion inside the magnetic field with angular speed omega, then induced EMF produced across this rod is given by equation 1/2 B omega R square or 1/2 B omega L square. Instead of R you can also consider length L square. So ये आपका मोस्ट इम्पोर्टेंट स्लोगन है आज के लेक्चर का. मोस्ट IMP JEE नीट शॉर्टकट। अब मैं आपको एक क्वेश्चन देता हूँ और मोस्ट ऑफ स्टूडेंट्स को आना चाहिए। देयर इज अ लॉन्ग मेटेलिक रॉड ऑफ लेंथ 1 मीटर। मेटेलिक रॉड ऑफ लेंथ 1 मीटर rotated with angular frequency 400 radian per second. Angular frequency 400 radian per second about an axis normal to the rod passing through its one end. The other end of the rod is in contact with circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla is applied perpendicular to it. चलो इस तरह ये देखो, ये सर्कुलर रिंग है, ये अपना रोड है, it performs rotational motion with angular speed omega and calculate the EMF developed between the center and ring. ये center है and this is ring, that means across this rod start EMF. Think about it, very easy. Now you can see frame all data with you and some concept also with you. Think about it. Pause the video, don't forget. Okay, तो आपने वीडियो पॉज करके सॉल्व किया हो. So EMF is equal to, you know that this is your most IMP shortcut 1/2 B omega L square 1/2 B already 0.5 omega 2 pi f, but here angular frequency already given, so not frequency but angular frequency, so directly I can write 400 length also 1 square, simplify and your answer should be 100 volt. तो ऐसे क्वेश्चन भी पूछ सकते हैं बोर्ड में. दिस इज योर NCERT टेक्स्ट बुक एक्सरसाइज 6.5. तो ये 6.5 नंबर अनसोल्ड यू कैन सी वेरी इजी. Only one formula and the game is over. So friends, think about this formula most IMP. फ्यूचर में अपन लोग इसके रिलेटेड काफी कुछ डिस्कशन करने वाले हैं, खास करके JEE नीट सेक्शन. So now we will think about few more question based on emotional EMF. तो एक और क्वेश्चन में अपन जाते हैं आज सिर्फ emotional EMF रिलेटेड न्यूमेरिकल्स एंड JEE नीट. तो आपने देखा 2-3 क्वेश्चन हमने JEE नीट के भी देखे, एक दो मस्त क्वेश्चन. Okay friends, so now you think about one more. यहाँ से मैं डेटा निकालता हूँ. A rectangular wire loop of sides 8 centimeter. You can see that like this one. 8 centimeter and 2 centimeter rectangular wire loop. It is placed in magnetic field. देखना न्यूमेरिकल में दम है. पहले मैं आपको ट्राई करने के लिए देता हूँ. Okay, then you have to think about, then we'll solve it. Okay, rectangular loop and moving out of region of uniform magnetic field of 0.3 Tesla. Whatever the magnetic field is present here, its intensity given 0.3 Tesla. This type of rectangular loop is already moving out of this magnetic field. Magnetic field यहाँ तक ये समझो, ये पूरा लूप है वो magnetic field में से बाहर आ रहा है, मगर वो आ रहा है तो कुछ स्पीड के साथ बाहर आ रहा है. Already here given what is the EMF developed across this loop if its velocity is 1 centimeter per second in a direction, velocity 1 centimeter per second but in a direction normal to magnetic field. Sorry, normal to, we can say that longer side, normal to longer side of a loop. Longer side of loop, you can see. Then okay, then your target to find simply first point EMF develop. And second question also there was how long does the induced voltage last in each case. दो cases दिए. पहला केस है, देखो ये पूरा question, this type of rectangular loop is given. What is the length of it? 8 centimeter, width 2 centimeter. It is already placed in magnetic field. You can see magnetic field going inside, and this loop is coming out, or I can say moving out of this magnetic field. ये magnetic field में से बाहर निकल रही. Magnetic field समझो यहाँ खत्म हो रहा है, ऐसा समझते हैं. And this magnetic field is completed no doubt up to here, but this loop is moving with speed 1 centimeter per second. But in such a way the velocity is already in the direction perpendicular to longer side. So tell me, out of these two sides you can see 8 centimeter is the longer side, तो velocity है वो longer side को perpendicular है. अगर यही क्वेश्चन पूछा होता कि वेलोसिटी इन द डायरेक्शन परपेंडिकुलर टू शॉर्टर साइड, तो अपन लोग ये वेलोसिटी का डायरेक्शन ऐसे लेते हैं, बिकॉज दिस इज टुवर्ड्स शॉर्टर साइड. तो अभी ऐसा पहला क्वेश्चन है कि अगर ये जो रोड है यानी कि लूप है वो मैग्नेटिक फील्ड में से बाहर इस तरह आ रही ताकि उसकी वेलोसिटी है वो जो ये दोनों साइड उसमें जो लॉन्गर साइड है उसको परपेंडिकुलर. सो टेल मी आउट ऑफ दिस टू व्हिच वन इज द लॉन्गर, 8 सेंटीमीटर, और वेलोसिटी देखो हमने परपेंडिकुलर ये डायरेक्शन में रखा, मतलब वेलोसिटी अपन लोग लेंगे. अगर यही क्वेश्चन पूछते हैं वेलोसिटी इज परपेंडिकुलर टू शॉर्टर साइड, then this loop is already moving in this direction. That means we have to consider velocity in this direction because velocity remains perpendicular to shorter side, particularly in this direction. But at present time we are thinking about the first case, velocity in direction normal to longer side. Okay, तो अब आपको एक क्वेश्चन ट्राई करना है. नो डाउट दो चीजें फाइंड करनी, इंड्यूस्ड ईएमएफ वो आपको पता चल गया, वेलोसिटी है, मैग्नेटिक फील्ड है, लेंथ भी आपके सामने है, और अब आपको फाइंड करना है टाइम, कितना टाइम लगेगा इसको मैग्नेटिक फील्ड में से बाहर आने के लिए. सो टेक योर टाइम एंड ट्राई टू सॉल्व इट. चलो तो अपने आप ट्राई करने का है क्योंकि अब आपने इतना पढ़ा है तो इतना तो कर ही सकते हो. ट्राई टू सॉल्व इट, डोंट वरी, इतना भी जोरदार क्वेश्चन नहीं है, यू कैन सॉल्व इट, डोंट वरी, ट्राई टू सॉल्व. चलो टेक योर टाइम, पॉज द वीडियो. ओके तो चलो अपन लोग ये सॉल्व करते हैं. फर्स्ट ऑफ ऑल यू कैन सी हियर वेलोसिटी इज परपेंडिकुलर टू लॉन्गर साइड. सो व्हाटएवर द मोशनल ईएमएफ इज प्रोड्यूस्ड, so motional EMF is developed in a loop. It is epsilon loop is equal to BALV. You know that very well. What is the formula of motional EMF due to the motion? Okay, what is the value B? It is 0.3 Tesla. Length we will consider here 8 centimeter because this is the, we can say, the portion already passing through magnetic field. So 8 centimeter, so 10 raised to minus 2. Here 1 centimeter, so 10 raised to minus 2 meter per second, you can see. And now if you simplify, then answer of this calculation is simply 2.4 into 10 raised to minus 4 volt. So obviously 2.4 into 10 raised to minus 4 volt EMF is developed inside the loop if this entire loop is moving out of this magnetic field. Why induced EMF is produced? Because here motion of this loop is taking place, and because of the motion whatever the magnetic flux associated with this loop or this entire area continuously changes. देखो सबसे पहले लूप यहाँ पे था तो 1 2 3 4 डायग्राम के मुताबिक समझे तो 1 2 3 4 तो 16 मैग्नेटिक फील्ड लाइंस बाहर आ रही थी. अब जैसे जैसे लूप बाहर निकलती जाएगी मैग्नेटिक फील्ड में से ऐसे ऐसे नंबर ऑफ मैग्नेटिक फील्ड लाइंस कम होती जाएगी, यानी कि जो लूप के साथ मैग्नेटिक फ्लक्स एसोसिएटेड है वो चेंज होता जा रहा है. एंड चेंज इन मैग्नेटिक फ्लक्स दैट मींस इंड्यूस्ड ईएमएफ. अब अपने को फाइंड करना है टाइम. सो व्हाट इज द वी कैन से द नेक्स्ट पॉइंट. इसमें बोला है how long does the induced voltage last in each case. तो चलो अपने को टाइम फाइंड करना कितने टाइम तक. सो टाइम इज टेकन to move. Time is simply, you can see that, taken to pull out or move out, pull out a given loop. Ready? So time का general formula क्या होगा? Time is equal to simply, you know that very well, the distance upon simply speed. Distance upon speed. What is the, we can say that distance. So distance कितना ट्रैवल करेगा, ये चिकना केस. तो अब देखो ये लूप यहाँ पे थी और यहाँ तक मैग्नेटिक फील्ड है, पूरी लूप है, देखते जाना बराबर. ये लूप है इधर, ये जिसे कह सकते हैं 2 सेंटीमीटर डिस्टेंस. ये लूप जैसे ही पूरा यहाँ से शुरू कर रहा है, देखो ये लूप पूरा मैग्नेटिक फील्ड में से बाहर आ जाए, that means this one is the last end, and whenever this entire loop is moving out of the magnetic field, that means it has to travels डिस्टेंस इक्वल टू 2 सेंटीमीटर। जब तक पूरी लूप बाहर ना आ जाए तब तक उसने कितना डिस्टेंस ट्रैवल किया 2 सेंटीमीटर, क्योंकि ये डिस्टेंस 2 सेंटीमीटर है। यहाँ से मोशन शुरू हुआ, देखो 2 सेंटीमीटर डिस्टेंस ट्रैवल करेगा तब ये एंड है वो यहाँ पे आएगा। दैट मींस डिस्टेंस ट्रैवल बाय दिस लूप 2 सेंटीमीटर, स्पीड ऑलरेडी 1 मीटर पर सेकंड में कन्वर्ट कर दो तो आंसर आएगा 2 सेकंड। सो ऑब्वियसली इट टेक्स, यू कैन सी दैट 2 सेकंड such that this entire loop can be pulled out. Okay friends, the same question you have to solve. The second segment, if you have to start second point, if speed v is normal or perpendicular to shorter side of or short side of a loop, then the same story, what is the induced EMF and what is the time. मतलब अब यही कहानी मैं डायग्राम इधर ड्रॉ कर रहा हूँ, वापस देखते जरा, यू कैन सी and this is, you can see that your loop, this is 8 centimeter, this is 2 centimeter. Now you can see as per given situation, speed remains, velocity remains perpendicular to shorter side, this is shorter side, so this is the direction of velocity. सिनेरियो चेंज हो गया, देखो यही डायग्राम में ड्रॉ करना होता तो ये यहाँ से हटा के v इस तरफ देखते, बट we would like to represent two different cases here, two different diagram, you can see. So apply your logic and tell me what is the EMF is developed particularly for this situation, and what is the time taken to pull out this given loop from the magnetic field. Pull out given loop from magnetic field. चलो, so pause the video and try to solve it. Think about it. Very easy. Induced EMF का तो फॉर्मूला होगा BLV again. So induced EMF epsilon is equal to BLV. B already 0.3 Tesla, but now length. What is the length of this side? 2 centimeters. So 2 into 10 raised to minus 2. Speed remains same. Simplify. 6, you can see 0.6 into 10 raised to minus 4 volt. This is your answer. And what is the time? So time taken to pull out this loop from the magnetic field, distance upon speed. What is the distance traveled? This is the most important. तो ये 2 सेंटीमीटर 8 सेंटीमीटर, इस एंड को यहाँ पे आना हो तो टोटल 8 सेंटीमीटर डिस्टेंस ट्रैवल करना पड़े, यानी कि 8 into 10 raised to minus 2, speed already, so it takes 8 seconds definitely. So this is the most time the numerical we have discussed. This is your unsolved number 6.4. Check it, unsolved number 6.4. Analyze friends, IMP for 3 marks. Okay, so this is very interesting number 6.4. So we have discussed 6.5, 6.6. अब अपन लोग जो क्वेश्चन सॉल्व करने जा रहे हैं, मेरे मुताबिक ये क्वेश्चन 2021 में होगा. दिस इज द आइडिया. जो मैं क्वेश्चन कह रहा हूँ उसको खास देखना, पूछने के पूरे चांस. और दूसरी बात इस क्वेश्चन की ये नीट जैसी एग्जाम में भी पूछ डालते हैं. सो बी अलर्ट, मोस्ट टाइम पे न्यूमेरिकल बेस्ड ऑन मोशनल ईएमएफ. ओके फ्रेंड्स, तो ये खास करने हैं. एनसीईआरटी में से कुछ न्यूमेरिकल्स आपने देखे सीधे जेडब्ल्यू नीट में डिफ्लेक्ट और रिफ्लेक्ट होते हैं. सो वी रीड द डेटा and most time question we would like to solve. Okay friends, so a horizontal straight wire, this is the horizontal straight wire of length 10 meter, this is 10 meter, you can see that 10 meter long wire is given, and as per given instruction long wire existing from east to west, here आपका east, here आपका west, असम से गुजरात, you can see east to west. Okay, and falling with a speed of 50 meter per second. here से है, here east west and falling with a speed 50 meter per second but at right angles to the horizontal component of the earth magnetic field. ये मैंने आपको बताया, earth magnetic field, horizontal component of earth magnetic field always from geographical south to geographical north. तो अगर ये east है, sorry ये ईस्ट है, ये वेस्ट है, सो वेयर इज जियोग्राफिकल साउथ? दिस इज साउथ एंड दिस इज नॉर्थ. तो ये रोड ऐसे नीचे आ रहा है, देखो यू कैन सी। तो अपन लोग डायग्राम में ड्रॉ करें, सो दिस इज ईस्ट टू वेस्ट एंड this is you can see that magnetic field and you can see the geographical south to geographical north, that means horizontal component of earth magnetic field। यानी पता चला, ये देखो आपका जिसे कह सकते हैं कि नॉर्थ साउथ, सॉरी ये साउथ है, नॉर्थ है, और ये ईस्ट वेस्ट मैग्नेटिक फील्ड में ऐसे यूं जिसे कह सकते हैं नीचे आ रहा है। दैट मींस इट रिमेन्स, इफ यू थिंक अबाउट वेलोसिटी ऑलरेडी perpendicular to magnetic field, ये ना मैग्नेटिक फील्ड देखो इसको परपेंडिकुलरली है, सो मोस्ट आईएमपी, और यही होना चाहिए मोशनल ईएमएफ के लिए। सो व्हाट इज द क्वेश्चन नंबर 1, व्हाट इज द अर्थ मैग्नेटिक फील्ड कंपोनेंट ऑफ अर्थ मैग्नेटिक फील्ड BH, वैल्यू ऑफ BH गिवन, इट इज 0.3 into 10⁻⁻4 वेबर पर मीटर स्क्वायर को टेस्ला अपन लोग लिख देते हैं। ओके, सो व्हाट्स द क्वेश्चन, 3 क्वेश्चंस दे आस्क। क्वेश्चन नंबर 1, व्हाट इज द instantaneous value of EMF induced in the wire? So we'll write EMF induced in wire. It is motional EMF definitely, so BVL. So B already 0.3 into 10⁻⁻4 as per given condition. Speed already given 50 meter per second. Definitely it is 50 meter per second given. Length already 10 meter. And if you simplify, then answer 1.5, 5 3 1.5 into 10⁻³ volt. This is your induced EMF. Second question पूछा है, what is the direction of this EMF? This is the most important point. First, second, direction of this induced EMF. अब ये मैं सिखाता हूँ क्योंकि ये हमने पहली बार जिक्र किया, क्योंकि इसकी राह देख रहे थे। अब हमने कितनी बार ऐसी गन चलाई, यू कैन सी दैट यूं ऐसा किया है, ऐसे करके यूं किया, याद आता है लेफ्ट हैंड रूल ने। सो हियर वी हैव टू अप्लाई द सेम कांसेप्ट एज पर यू कैन सी दैट फ्लेमिंग्स राइट हैंड रूल। तो ये राइट हैंड रूल देखो कैसे अप्लाई करना है, यूं अगेन यूं निकाली गन यूं। अब इसमें फंडामेंटली देखो तो ये पूरी कहानी में दिस इज यू कैन सी दैट द डायरेक्शन ऑफ मोशन, कौन सी डायरेक्शन में जिसे कह सकते हैं कि बॉडी मोशन कर रहा है। अपना केस चेक करो, हियर दिस कंडक्टिंग रोड मूव्स इन डाउन डायरेक्शन, सो थंब ऑलरेडी इन डाउन डायरेक्शन। तो देखो ये रहा थंब ऑलरेडी इन डाउन डायरेक्शन, रेडी। एंड दिस फिंगर यू कैन सी द फोर फिंगर सिंपली रिप्रेजेंटिंग मैग्नेटिक फील्ड डायरेक्शन। तो अपने केस में मैग्नेटिक फील्ड अंदर जा रहा है, देखो मैग्नेटिक फील्ड। देन दिस मिडिल फिंगर गिव्स आइडिया अबाउट द डायरेक्शन ऑफ इंड्यूस्ड EMF। ओके, तो अपन लोग इधर अप्लाई करते हैं वंस अगेन फ्लेमिंग्स राइट हैंड रूल मेथड टू फाइंड डायरेक्शन ऑफ इंड्यूस्ड EMF। जब भी इंड्यूस्ड EMF की डायरेक्शन फाइंड करना हो, थिंक अबाउट फ्लेमिंग्स राइट हैंड रूल। थंब द डायरेक्शन ऑफ मोशन ऑफ बॉडी, finger forefinger you can see that this first finger simply gives idea about the direction of applied magnetic field and this middle finger gives idea about direction of induced EMF। तो इधर अप्लाई करते हैं, तो देखो इधर अप्लाई करना हो तो ये फोर फिंगर अंदर जानी चाहिए तभी पार। तो मैं देखो ऐसा हो गया परफेक्ट। चेक दिस पॉइंट, each and every point, this four finger you can see, four finger simply representing magnetic field, thumb represent direction of motion, then this is the direction of induced EMF। So induced EMF is produced as per this situation, induced EMF is produced in this direction, so this is the direction of induced EMF। So direction of induced EMF from simply west to you can see that east, मतलब ये पॉजिटिव पोटेंशियल है नेगेटिव। सो थर्ड क्वेश्चन भी यही पूछा है, डायरेक्शन पता चले एज पर अपन लोग लिख देंगे एज पर फ्लेमिंग्स right hand rule। okay, you can also apply the concept of F is equal to QV cross B in S, मगर ये सबसे इजी रहेगा। सो आंसर आएगा वेस्ट टू ईस्ट। थर्ड क्वेश्चन है which EMF of the wire is at the higher electrical potential, or which end of the wire, sorry, which end of the wire at higher electrical potential, obviously high to low, so western end, so we'll write here the western end is at higher potential, you can see। So So this is the most IMP question. 3 already targets. Number 1, find the induced EMF, find the direction of induced EMF, and out of these two ends, which end is the higher potential, because west to east, so current flows from west to east. That means west at high potential, east at you can see that low potential. So this is the marvelous question number 6.7, textbook NCERT 6.7 आइडियल पेपर का मोस्ट टाइम पे क्वेश्चन पूछेंगे 2021 के लिए, क्योंकि पेपर इजी हो, आइडियल हो, उसके लिए आइडियल 3 मार्क्स में ये आना चाहिए और पूछ सकते हैं 1 2 3 मोस्ट आईएमपी. सो दिस इज द सुप्रीम क्वेश्चन. एनालाइज विथ योर वी कैन से द टेक्स्ट बुक रेफरेंस. ओके, सो नाउ वी वुड लाइक टू सॉल्व नेक्स्ट. ये भूलना नहीं है, देखो Fleming's right hand rule again. By using Fleming's right hand rule, we can find the direction of induced EMF like this one. पहले यूं गन निकालो, then यूं गन खुलनी चाहिए, यूं रह गई, लोचे हो जाएंगे. So thumb represent the direction of motion of body. First finger representing direction of applied magnetic field. Then this middle figure gives idea about the direction of induced EMF. Super. Okay. Now we would like to solve मास्टरपीस. चलो, ये जो क्वेश्चन है वो खास जेडब्ल्यू नीट के लिए बन सकता है आईएमपी. तो देखो जरा, ये थोड़े क्वेश्चन टिपिकल अपन देखते हैं. सो मोशनल ईएमएफ रिलेटेड हमने डिस्कशन भी शुरू किया है, वो एक पूरा लेक्चर मोशनल ईएमएफ में रहना है. सो एनसीईआरटी हमने देखा, साथ में एनसीईआरटी के सभी मोशनल ईएमएफ न्यूमेरिकल हम लोग कवर कर रहे हैं. सो ये जो है वो बहुत ही मास्टरपीस है. सो बी अलर्ट. ओके फ्रेंड्स, सो दिस इज यू कैन सी दैट वन ऑफ द मोस्ट इंपोर्टेंट क्वेश्चन. स्क्वायर लूप ऑफ साइड 12 सेंटीमीटर. So this type of square loop of side 12 centimeter, length of side 12 centimeter. Okay, 12 centimeter parallel to x and y axis moves with a velocity of 8 cm per second in the positive x direction. So we'll set up the coordinate system. You can see this is positive x and this is positive y. That means remains parallel to x and y. ये x को parallel है, y को parallel हो गया. And this entire square loop is moving with 12 meter per second or centimeter per second. Okay, 8 centimeter per second. Sorry. 8 centimeter per second. It is moving with speed 8 centimeter per second. Length already given 12 centimeter. Okay, next most important. Now you can see here magnetic field is applied in the direction of z, positive z axis. The field is neither uniform in space nor constant in time. Uniform electric field नहीं है, sorry, magnetic field. Magnetic field doesn't remain uniform. That means magnetic field continuously changes, but continuously changes with respect to time as well as with respect to distance. So ये जबरदस्त point है, just check it. And it has a gradient of 10 raised to minus 3. Gradient मैं लिख रहा हूँ इधर नाम, gradient. Sorry. Gradient of 10 raised to, you can see that 10 raised to minus 3 Tesla. Gradient पहले लिख देते हैं. Gradient 10 raised to minus 3 Tesla per centimeter. याद करो, ग्रेडियंट हमने देखा है, पोटेंशियल ग्रेडियंट, पोटेंशियल पर यूनिट लेंथ. याद आया? वेलोसिटी ग्रेडियंट, वेलोसिटी पर यूनिट लेंथ. सो मैग्नेटिक फील्ड ग्रेडियंट, मैग्नेटिक फील्ड पर यूनिट लेंथ. So this is called simply dB by dt. The rate of change of, dB by dx, rate of change of magnetic field, but with respect to, you can see the distance. So most IMP. Next, and magnetic field also changes as per, or it is increases by 10 raised to minus 3 Tesla per, we can say that second. There is a, we can say that 0.3 Tesla. dB by dt also given 10 raised to minus 3 Tesla per second. So ये रेट से मैग्नेटिक फील्ड बढ़ रहा है पर सेंटीमीटर. ये डायरेक्शन में आप जैसे जैसे आगे बढ़ो 10⁻³ टेस्ला मैग्नेटिक फील्ड बढ़ रहा है, मैग्नेटिक फील्ड बढ़ रहा है, दैट मींस कंटिन्यूअसली uniform magnetic field is not possible here. Continuously if you move in this direction, then per centimeter there is 10⁻³ Tesla magnetic field increases. And with respect to time, magnetic field also we can say the change is as per this data 10⁻³ Tesla per second along the negative x direction. And here you can see that one more important information given, and it is decreasing in the time at the rate of 10⁻³ टेस्ला पर सेकंड. ये जो पॉइंट है अपन लोग ऐसे आगे बढ़ेंगे और नेगेटिव एक्स एक्सिस डायरेक्शन में मैग्नेटिक फील्ड है वो इंक्रीज हो रहा है, ये डायरेक्शन में मैग्नेटिक फील्ड इंक्रीज हो रहा है, मतलब अपन लोग कौन सी डायरेक्शन में जा रहे हैं, इन द डायरेक्शन ऑफ डिक्रीजिंग वैल्यू ऑफ मैग्नेटिक फील्ड. ये लोगों ने बोला नेगेटिव एक्स एक्सिस है उसकी डायरेक्शन में मैग्नेटिक फील्ड है वो डिक्रीज हो रहा है, इंक्रीज हो रहा है, तो अपन लोग इस साइड जा रहे हैं, दैट मींस इन द डायरेक्शन ऑफ डिक्रीज. मगर मैं ये सब डिक्रीज इंक्रीजिंग में आपको बाहर लेना चाहता हूं क्योंकि इसमें कुछ टेंशन नहीं. एक चीज याद रखनी है यहाँ पे, विथ रिस्पेक्ट टू टाइम एंड विथ रिस्पेक्ट टू डिस्टेंस मैग्नेटिक फील्ड कंटिन्यूअसली चेंजेस. Forget about negative, positive, decreasing, increasing. Only one point is very IMP. Magnetic field doesn't remains constant. In magnetic field doesn't remains constant, that means we are discussing about non-uniform magnetic field. Non-uniform magnetic field, that means you know that very well, whatever the magnetic flux associated with this loop continuously changes. जैसे जैसे लूप ए डायरेक्शन में जाए, इधर जाए, उधर जाए, इधर जाए, don't worry. But whenever this loop perform motion, then it is clear that it is performing motion or it perform motion inside the non-uniform magnetic field. Non-uniform, that means continuously magnetic field changes. Magnetic field changes, magnetic flux changes, magnetic flux changes, induced EMF. तो इधर induced EMF अपने को प्रोड्यूस कितना होता है वो फाइंड करना है. But here induced EMF is produced due to two types of magnetic field changes. Number one, because of magnetic field change with respect to distance, and because of magnetic field with respect to time. तो अपन लोग क्वेश्चन को एक कदम पहले मैं पढ़ लेता हूँ, जिसको पता ना चले वो आपको टेक्स्ट बुक का रेफरेंस भी ले सकते हैं 6.12, डोंट वरी. सो आप टेक्स्ट बुक थ्रू भी चेक कर सकते हो. नाउ द फाइनल आंसर क्या पूछा है, डिटरमाइन द डायरेक्शन एंड मैग्नीट्यूड ऑफ द इंड्यूस्ड करंट इन द लूप इफ द रेजिस्टेंस इज 4.5 मिली ओम. रेजिस्टेंस 4.5 मिली ओम. तो सबसे पहले ऐसे न्यूमेरिकल के लिए अपन लोग जिसे कह सकते हैं कि एक फंडामेंटल कॉन्सेप्ट अप्लाई करते हैं. अपने पास dBdx है वो dBdt है. ओके, dBdx मतलब मैग्नेटिक फील्ड पर यूनिट लेंथ एंड dBdt मैग्नेटिक फील्ड पर यूनिट टाइम. सबसे पहले अपन लोग शुरू करते हैं इंड्यूस्ड ईएमएफ. अपन लोग तो जानते हैं इंड्यूस्ड ईएमएफ क्यों होगा, एज पर फैराडेज लॉ. तो पहले लिख देते हैं ऐसा हो तो एज पर फैराडेज लॉ induced EMF is produced in a loop. But here induced EMF is produced due to change in magnetic flux. But magnetic flux here changes because of two different ways. Number one, because of with respect to distance and with respect to time. अपन लोग जिसे कह सकते हैं कि इसमें टोटल induced EMF पूछा है, तो अपन लोग शुरू करते हैं फर्स्ट केस. Okay, induced EMF is produced in loop due to change in magnetic field with you can see that distance. चलो तो अपन लोग डिस्टेंस रिलेटेड देखें तो इट इज सपोज एप्सिलॉन 1. सो व्हाट इज द फॉर्मूला ऑफ इंड्यूस्ड ईएमएफ, डी फाई बाय dt से शुरू करते हैं एज पर फैराडेज लॉ, डी फाई बाय dt. सो d dt, व्हाट इज द फ्लक्स, फ्लक्स इज द magnetic flux, that means product of area and magnetic field AB. So area already constant, so only dB by dt. ये तो कॉमन ही रहेगा, बराबर. अब देखो इधर t है, dt, नो प्रॉब्लम. अपने पास जिसे कह सकते हैं dB by dt की वैल्यू है. व्हाट इज द dB by dt, नो डाउट. सो बट वी हैव टू थिंक अबाउट डिस्टेंस, देयर इज अ मिस्टेक, सॉरी. तो अपन लोग इधर टाइम कर देते ताकि पहला इजी हो जाए. चलो, सो मैग्नेटिक फील्ड विद टाइम, तो आगे मैग्नेटिक फील्ड विद टाइम. व्हाट इज द एरिया ऑफ दिस लूप, लेंथ है तो L स्क्वायर dB by dt. So what is the answer, epsilon 1, length 12 centimeter, set up the value 12 into 10 raised to minus 2 the square, and dB by dt 10 raised to minus 3. Okay, if you simplify then I can directly answer it is 1.44 into 10 raised to minus 5 volt. So this is the induced EMF produced inside this loop because of change in magnetic field with respect to time. अब देखो कुछ लोगों को ये न्यूमेरिकल में लास्ट तक समझ में नहीं आता, सोल्व कर देते हैं। नंबर 1 देखो अच्छी तरह, सबसे पहले इधर मैग्नेटिक फील्ड है, उस मैग्नेटिक फील्ड को मैं टाइम के साथ चेंज कर रहा हूं और ये लूप इधर ही रखता हूं। डोंट फॉरगेट लूप इज स्टेशनरी, नो प्रॉब्लम। ये लूप इधर है, पहले वेलोसिटी को छोड़ दो, ये लूप के ऊपर मैंने मैग्नेटिक फील्ड अप्लाई किया, मगर वो मैग्नेटिक फील्ड की वैल्यू में कंटिन्यूअसली चेंज कर रहा हूं विद रिस्पेक्ट टू टाइम। पर सेकंड मैं 10⁻³ टेस्ला मैग्नेटिक फील्ड चेंज कर देता हूं। तो इधर जो लूप है उसके ऊपर जो मैग्नेटिक फील्ड अप्लाई किया वो कंटिन्यूअसली चेंज होगा बिकॉज ऑफ चेंज इन मैग्नेटिक फील्ड। व्हाट हैपन? इंड्यूस्ड ईएमएफ इज प्रोड्यूस्ड। तो इसके लिए ये जो पहला केस हमने डिस्कस किया, इसके लिए मोशन की कोई जरूरत नहीं थी क्योंकि विद रिस्पेक्ट टू टाइम व्हाट हैपन, कंटिन्यूअसली अप्लाइड मैग्नेटिक फील्ड चेंजेस। तो इसलिए हमने पहला केस सेक्शन डिस्कस किया जिसमें इंड्यूस्ड ईएमएफ इज प्रोड्यूस्ड इन लूप ड्यू टू चेंज इन मैग्नेटिक फील्ड विद टाइम। इसमें मोशन की कोई जरूरत नहीं है, ये लूप ऐसे ही पड़ा हो तो भी टेंशन नहीं। अब दूसरा पॉइंट ये लोग बोला अगर ये लूप मोशन में हो तो अपन लोग टाइम के साथ मैग्नेटिक फील्ड चेंज हो रहा है, प्लस जिसे कह सकते हैं कि देखो पर डिस्टेंस पर यूनिट लेंथ मैग्नेटिक फील्ड आल्सो चेंजेस। तो जैसे जैसे ये बंदा आगे बढ़ेगा 1 सेंटीमीटर डिस्टेंस ट्रैवल करेगा, पर सेंटीमीटर मैग्नेटिक फील्ड 10⁻³ टेस्ला जितना चेंज होता है। मतलब इधर अपन लोग जिसे कह सकते हैं कि मोशनल ईएमएफ का भी फंडा अप्लाई कर सकते हैं। तो सेकंड केस नाउ इंड्यूस्ड ईएमएफ is produced in a loop due to change in magnetic field with distance, no problem। तो with distance देखो, distance हमारे लिए important होगा। So again epsilon 2 it is d phi by dt, magnetic flux आप जानते हो, area into magnetic field, area out of differentiation। Okay, area you know that very well, it is simply L square। Now you can see the dV by dt। So most of students say okay what you done, because all situation are same, आपने जो किया वापस वही का वही आ गया, no difference at all। मगर difference है here we are thinking about induced EMF because of changing magnetic field with respect to distance, just check it। So with respect to distance, that means here dV by dx plays important role। So how can you obtain dV by dx? So for that we have to think about some mathematical moment। You can see divide and multiply by dx, so it is a dV by dx। And what do you mean by dx by dt? Differentiation of distance with respect to time, it gives speed। So epsilon 2 area already we can say that here 12 into 10⁻² the whole square, dV by dx already with you 10⁻³ Tesla per centimeter, and speed already with you। You can see what is the speed already with you 10⁻³ Tesla per centimeter है, तो पर यूनिट के लिए 10⁻² वापस कर देता हूँ क्योंकि अपॉन 10⁻² का प्लस आ जाएगा, इनटू स्पीड ऑलरेडी 8 into 10⁻², just check it। तो ये सभी वैल्यूज है, if you simplify and set up the values, then answer would be 11.52 into 10⁻⁵ volt। So this is the induced EMF due to change in magnetic field with respect to distance, and this is the induced EMF due to change in magnetic field with time। So what is the total EMF? So total EMF epsilon 1 plus epsilon 2। So epsilon 1 it is 1.44 into 10⁻⁵, and epsilon 2 11.52 10⁻⁵। So if you simplify 12.96 into 10⁻⁵ volt answer। This is your induced EMF। But your target to find induced current, so induced current I is equal to, as per Ohm's law, epsilon by R। Epsilon already 12.96 into 10⁻⁵, R already given 4.5 milli, so 10⁻³ milli because of -3, and that's why if you simplify then answer would be 2.88 into 10⁻⁻⁵ minus 2 ampere. So this is the, you can see that induced current produced. Here current is produced due to two reasons, because of change in magnetic field with respect to time and because of change in magnetic field with respect to distance. So supreme, but I would like to find the direction of current. How can you find direction of current? Just apply your logic and tell me. Suppose you would like to answer, or you would like to check the direction of current, then simply apply right hand Fleming rule. Fleming's right hand rule, you can see this is the thumb represent direction of motion. अपने केस में देखो motion ये direction में, in the direction of positive charge, magnetic field going inside as per given data. So this middle finger simply represent direction of current. So current flows in this direction, already represented here, you can see. So this is current, it is already in anti-clockwise direction. So I can write induced current is observed in anti-clockwise direction. Most timely, and this is your 6.12 number question, one of the supreme, you can see that question, and very important for 3 or 4 marks. Friends, so we have discussed today all NCERT related best numericals based on emotional EMF. Next time we would like to think about few more JEE NEET and then next topic. सुपर. तो 4 पार्ट्स हमने डिस्कस किए, 4 पार्ट्स में 2 जबरदस्त टॉपिक कवर किए, फेराडेस लॉ एंड यू नो दैट वेरी वेल इमोशनल ईएमएफ. तो इसको अच्छी तरह देखो. नेक्स्ट टाइम और मिलते हैं दोस्तों.